Hi Ethan, we are going to learn about identifying parallel and perpendicular lines today. This we have discussed with you if this is x-axis and y-axis here. Okay, so this is x-axis and y-axis, and there is a line which is crossing here. Okay, and we can extend it this point. Okay, and it is meeting on this line. Okay, so this yellow color line, like this one, this is called y-intercept, that is C, and equation of this line is given by y equal to mx plus c. Okay, so in today's lesson where m is gradient, we are learning about what will be the condition of parallel line and what will be condition of perpendicular line. So if lines are parallel, then their gradient will be equal. M1 equal to M2. Okay. If lines are parallel, their gradient will be equal. If lines are perpendicular, then product of the gradient like M1 times M2, it should be -1. Okay. So these two are conditions. So let me write down clearly here. Okay. So this is -1. M1 times M2 equal to -1. Okay, let's see a couple of examples, and in these examples you need to find whether lines are parallel or perpendicular. If I say y equal to 2x plus 3 and y equal to 2x plus 7. Okay, so in these two lines, whether these two lines are parallel or perpendicular. So this is what we need to find. So if you see here with x, what is here? 2. With x, what is here? 2. So in both the equation, gradient is same. Why it is called gradient? If you compare this equation with y equal to mx plus c, so m you got here 2. And similarly m you got here too. So if gradient are same, so lines are parallel. So you can say these two lines are parallel. Okay, I'm putting parallel sign here, or you can write down parallel. Okay, now let's see another question. If I say question number 2, y equal to 2x plus 3 and y equal to minus half x plus 7. Okay, if you see here gradient is 2, here gradient is -1 over 2. Now you must be surprised why I'm calling it gradient 2. So if you see equation y equal to mx plus c, so whatever is with x, okay, that is called gradient. Sorry, singly gradient, and this c is called y intercept. Yeah. Okay, so see, so in this equation here, gradient is 2, so m1 is 2, and here gradient is -2. So definitely they are not equal. So m1 is not equal to m2. But if you multiply m1 times m2, are you getting -1? Let's see. m1 is 2, m2 is minus half, so top 2 cancel by bottom 2, so we are getting -1. So this shows lines are perpendicular. Okay, now I can show you one more question. Okay, so okay, now question number 1 is if y equal to 3x plus 5 and y equal to minus 2x plus 5. So are these lines are parallel or perpendicular or none? So if you see, with x what is here? 3. With x what is here? 2. So they are not equal. So gradients are not equal. So lines are not parallel. So lines are not parallel. Okay. And if you multiply them like 3 and minus 2, if you multiply, you're getting minus 6, you're not getting minus 1. So lines are not perpendicular either. So lines are not perpendicular. When it will be perpendicular? When this is coming as minus 1. But here is coming minus 6, so lines are not perpendicular. Okay. If we see here, y equal to minus 3x plus 2, and here y is 1 over 3x minus 5. Okay, so here gradient is m1, that is minus 3, and m2 is 1 over 3. Okay, so here first gradient is minus 3, second gradient is 1 over 3. So they are not equal, so lines are not parallel. But if you multiply first gradient with second gradient, like minus 3 times 1 over 3, so you're getting minus 1. So it means lines are perpendicular. Okay, lines are perpendicular. Now I'm giving you a couple of questions. You need to find whether lines are parallel, perpendicular, or none. Okay, so questions are here. So here are 5 questions, and you need to find whether lines are parallel, perpendicular, or none. Okay, show your working, and please pause the video and have a go. So welcome back if you have tried. So if you see here, here gradient is 2 and here gradient is 3. So you can say here m1 is 2 and m2 is 3. So they are not equal, and if you multiply they are not getting minus 1. So lines are not parallel and perpendicular. Yeah, so answer is none. Not perpendicular and not parallel. If you see here, gradient is minus 3 and here gradient is minus 3. So m1 is minus 3 and m2 is minus 3. So lines are parallel because gradients are equal. So lines are parallel. If you see here, gradient is half and gradient is minus 1. So they are not equal, and if you multiply, you are not getting minus 1 either. So lines are not perpendicular and not parallel. So none. If you see here, m1 is 2 and m2 is minus half. So definitely they are not equal, but if you multiply m1 times m2, like 2 times minus half, then you get minus 1. So it means lines are perpendicular. Okay, perpendicular. Okay, and if you see here, m1 is minus 3 and here m2 is also minus 3, right? So they both are equal, so lines are parallel. I hope things are clear. I'm giving you another set of questions. Please try, and then after that you can check your working. So please try these 5 questions and find out whether lines are parallel or perpendicular or none. Please pause the video and have a go. So welcome back if you have tried. So if you see here, m1 is -2, m2 is half. So if you multiply them, like m1 times m2, that like -2 times half. So 2 and 2 cancelled out, you're getting -1. So lines are perpendicular. So we can write down here, lines are perpendicular. Okay, here gradient m1 is -5, here m2 is 5. So they are not equal, and if you multiply them, you are not getting -1. So answer is none, neither parallel nor perpendicular. Okay, here m1 is -half, m2 is 2. So they are not equal, but if you multiply, so -half times 2, 2 and 2 cancel out, so you are getting -1. So lines are perpendicular. Okay, so lines are perpendicular. Okay, here gradient is 6, here also gradient is 6. So both the gradients are equal, so lines are parallel. Okay, and the last one, here gradient is -6, and here also gradient is -6. So both the gradients are equal, so lines are parallel. Okay, so I hope you have enjoyed the video. So in next video we will learn something new. Till then, goodbye. Thanks for watching.